find the sum, if possible, of the series the square root of 27 plus the square root of 9 plus the square root of 3 plus so on and so on. Well, here we have we do see a pattern. Underneath the square root, we're just dividing by 3 each time, okay, to get to the next term, or in other words, multiplying by 1/3. But because of the square root, this means that we're actually, from term to term, multiplying by the square root of 1/3. And so we have a geometric sum here with r as the square root of 1/3. Another way to write that is 1 over the square root of 3, if you'd like. And the absolute value of this, of course, is less than 1, because the square root of 3 is, 1.7 something. So this is less than 1, so the sum will exist. And the sum for an infinite geometric series is the first term over 1 minus the common ratio. So the first term is the square root of 27 over 1 minus the common ratio, 1 over root 3. And there's not much we can do to simplify. I will, because we've got a nested fraction here, we'll get rid of that denominator. So we're going to multiply by root 3 over root 3. And in the numerator, we get the square root of 81, which is simply 9. I guess I'll do that in a second. And in the denominator, if we distribute, we get the square root of 3. And then minus 1 over that times root 3 is just minus 1. So this is 9 over root 3 minus 1. There's our sum. And if you want, you can rationalize the denominator. But I don't think it's really necessary. So there's our sum.